So in the previous video, we spoke about how we could use video as a way of displacing our the z-axis component of our videos. So we're gonna keep going on that in the future, but for now, we're gonna see how we can do that using mathematical functions that do it automatically for us. If you look at the patch, you'll see that I included a new object, the jit.mo.time object, which isn't part of Max by default. You have to download it from the package manager. But if you just instantiate it with no arguments or no attributes, it's just going to start counting upwards, which is exactly what I need for the time being. I'm going to come over here and I'm going to make a new parameter called offset. And if I connect this value into this vector, you can see how whatever value I have here is going to be the same as the one I have over here. That's because I'm writing that particular value into that plane of my matrix. So if I restart this, you're going to see how it starts increasing until you can't see it anymore. So instead of just counting on the count of the jit.mo.time, I'm going to actually do something with that number. So let's start simple. Let's just multiply it by, let's just get the sine function of that number. So it's going to increase and decrease. It's just going to follow simple harmonic motion. We can see how the z-axis is going between 1 and -1 in the z-axis. So when it's at -1, it's really far away, and when it's at +1, it's really close. So we can see that as changes in kind of size and distance. And this is very cool, but what if we could have a different value for each kind of column or row? Well, that's actually not that complicated to do. We can just do that by adding the offset to, I'm sorry, I forgot the add. By adding our offset to either the x or y axis, whichever we want to affect. So we can see how this is kind of now curving up and down, and it's not always, like, it's not moving jointly, it's kind of bending. And if I were to multiply this against 2 pi, the curve would be more evident. So I can just write times 2 pi. And 2 pi is a constant in gen, so you don't have to define it, it's just type 2 pi. We can see how it looks more and more like a sine wave. Maybe that's too wild, let's just type pi. Right, so that's pretty cool. We can see how all of the points are moving following a sine wave, and it's being adjusted throughout the x-axis. We can do the same with the y-axis, or both. Let's see what happens with both. Pretty interesting. So let's keep it just with the x-axis for now. We can also change the depth of the modulation by adding a multiplier over here. So something you could foreseeably do is have a depth parameter and include here param depth, and then go over here, depth $1, send that over to jit.gen, and this would let you this would allow you to control the depth of your modulation. It's pretty cool, I think. So I'm just increasing it, and it's going to become more and more and more. So we can join this idea with the idea that we had in our previous patch of using video. So let's just do that. I'm gonna do it like right away. So I'm just gonna get a jit.grab, open jit.rgb2luma, and I'm not gonna flip it just because it doesn't really matter at this point. And I'm gonna take in2, and I'm just gonna add it with whatever value we have over here. So just add. And I'm going to connect that output from RGB to Luna. So I'm going to see my face. This is me, hello. Maybe I'm going to increase the point count just so that it's more clearly me. And it's going to be flipped around. That's something that we need to do from outside, but we're just going to leave it here for now. And now we can actually modulate this with a sine wave. which is pretty cool, right? You can have an incoming video source and then modulate it with anything that you might possibly want. So this gives you a lot of options because you don't have to use a simple video input like this. You could also be using some more complex video input. But I think that this is also very cool, like for live performances, because you could have pretty low resolution camera, like a webcam, like I do right now, and by uh, doing this, you could add effects in real time that make it more interesting and make good use of the resources that you have. Like, for example, I'm just going to bring over my guitar 1 second and show you how that would look like. Actually, no, I'm just going to get an apple. Apples are more interesting than guitars. So something as simple as an apple looks super interesting here. And the texture of all of these things looks really cool. And you can actually read what's on my shirt, I guess. So that's just one way you can modulate these things. Maybe let's have the depth be less heavy. And you can also change the scale. And the cool thing is that any kind of processing that you might be able to do in GL, you'll be able to do in here. So that also opens a bunch of very exciting doors. So I guess this is it for this tutorial. Let's look at other modulation methods in the next video.